number 1 says, if 2/3 of the pie below is eaten, what fraction remains? First, we need to find 2/3 of the pie below. How much of this pie is here? What fraction is it?
3/4.
3/4. So I need to find 2/3 of 3/4. That's my starter. That's what I need to do. So I define 2/3 of 3/4. And what does it mean when you say of in math? We're going to multiply. And before I do my multiplication, well, I'm actually not, yeah, I guess I'll reduce. Reduce by 3, which is 1 and 1. So 2 times 1 is 2. 1 times 4 is 4. The reason why I didn't reduce the 2 and the 4 is because of the next step. That is what was eaten, right? I need to take that from the fraction that was there. So now I need to take, and then we said the fraction that was there was 3/4. So now I take 3/4 minus 2/4. That's why I didn't reduce, because this way I have a common denominator. And 3 minus 2 is 1. So 1/4 of the pie is what remains.
I had the answer the whole time, but I didn't know.
2 is what we're working on in this chapter. 7 8/10 times 9/4. You can either change the decimal to a fraction or the fraction to a decimal. What do I like to do? I like to do the fraction to a decimal because it makes it easier. So I'm just going to go 9 divided by 4. 4 goes into 9.
4 times.
2 times. 1 left. Add a decimal. Bring that decimal up. 4 goes into 10. 2 times. 2 left. Add a 0. And 4 goes into 20. 5 times. So now I have 2 and 25/100 times 7 and 8/10. When you're multiplying with decimals, you don't worry about the decimals. So I put the one with the most digits on top. 2 and 25/100 times 7 and 8/10. I first just go ahead and multiply through. 8 times 5 is 40. Carry the 4, leave the 0. 8 times 2 is 16 plus 4 makes 8 times 2 is plus 2 makes. Cross off what I've used. Add a 0. 7 times 5 is
35.
Carry the 3, leave the 5. 7 times 2 is
14.
14 plus 3 makes
17.
Carry the 1, leave the 7. 7 times 2 is 14 plus 1 makes
15.
Add it all up, and 8 plus 7 is 15. Carry the 1. Now I go back and I count my decimals. 1, 2, 3. Start on the right and come in left. 1, 2, 3. So my answer would be 17.550, but I don't really need that 0, so I can rewrite it as 17 and 55/100. If you kept the 0, that's okay. I'm not going to count it wrong. Yes.
I did it differently and I still got 17.5.
Did you put the 7.8 on top?
I did 7.8 over 1 times 9 over.
You cannot put 7.8 over 1.
Oh, that's what I did. And then I divided 4 divided by 70.2 because that's what I got, and I got 17.5.
You can't do that. All right, another way to do that, I'm going to show you. I could have taken 7 and 8/10 times 9/4. I'm going to show you by changing my decimal number to a fraction. So this would be 7 and 8/10 times 9/4. 7 and 8/10 is really going to be 78/10 times 9/4. You see where this gets a little bit harder? I'm going to reduce by 2. That becomes a 2. This becomes a 39. So now I have to take 39 times 9. Do you guys know 39 times 9?
No.
No.
I don't either.
That's right, calculator.
Or you would actually have to write it up and down, so that's 351 over 20. Then when I do that division, it would be 17 and 11 20ths. Isn't that a little bit harder than just multiplying up and down?
Yes, sir.
So think about that when you go to do the problems. Number 3, we have x divided by 6 plus 12 equals a negative 12. You can, yes, one is positive, one is negative, but you cannot say that they are additive inverses because an equal sign splits them up. So we're going to keep the x divided by 6 by itself. Then we're going to do the additive inverse. So instead of adding 12, we are going to subtract 12 on both sides. So we're left with x divided by 6 equals. Now we have a negative 12 and a negative 12, which makes a negative 24. Then we're going to box the x. So this is like saying x divided by 6. So the opposite would be multiply by 6. They cancel each other out. Multiply this side by 6. X equals a negative 144.
Nice try, Carter.
And make sure you're boxing your answer.
I actually divided.
Number 4, the greatest common factors of 8x and 22xy. Thank you. To find the prime factorization of 8, it would just be 2 times 2 times 2 times x. Prime factorization of 22 would be 2 times 11. So it's 2 times 11 times x times y.
2 and 2
They have the 2's in common
and the x.
and the x's. So the greatest common factor of these is 2x.
And box your answer.
Number 5, I gave you the formula with the x. So it said 2/3 times x, this is one side, plus 10. And we said x equals 30. So you make it 2/3 times 30 goes over 1 plus 10. So I'm going to reduce by 3. 3 divided by 3 is 1. 30 divided by 3 is 10. So 2 times 10 is 20, and then we have 20 plus 10, which would be, we do this again for the other side. 1/3 x plus 5. So now I have 1/3 times 30 over 1 plus 5. Reduce by 3. 1 times 10 is 10 plus this 5. So one side is 30 and the other side is 15. Number 6 is exactly like what we did yesterday. No, excuse me, no, not exactly. Number 6 is like what we've done on last week. 4m minus 4 minus 8 equals a negative 2m plus 12. The difference with this one is that I've got letters on both sides, numbers on both sides. I either need to bring this m over here or this m over here. But before I do that, I want to do some combining on each side if I can. So now I'm left with 4m. What's a negative 4 and a negative 8? Negative 12. So I have 4m minus 12 equals, and I can't combine anything over here, so it's just gonna equal negative 2m plus 12. Now I'm going to either bring the 4m over here or the 2m over here.
2m.
I'm going to move the 2m because right now it's negative, so this way I'll make it positive. So I'm gonna say plus 2m plus 2m. So now I have 6m minus 12, those canceled each other out, equals 12. Box that 6m. How do I get rid of that negative 12? Add 12. Add 12. So now I have 6m equals 24. Now to get the m alone, box it up, divide by 6, they cancel each other out. Divide by 6, so m equals 4. Now I'm on to 7, which is like yesterday's. A living room wall is 11 feet long. How far from the corner would you have to the edge of a 2-foot 6-inch shelf for it to be centered on the wall? So I'm gonna draw my picture. You guys should all draw your picture.
You're off.
Here's my wall. And my wall is 11 feet. My shelf is in the center of that, and that's 2 feet 6 inches. So there's my shelf right there, right? I need to figure out those spaces. So first I need to take my whole length of the wall and subtract the length of the shelf. So I have 11 foot minus 2 feet 6 inches. Now with any subtraction, can I take 6 away from nothing? Yes or no?
No.
No. So you have to borrow. But when you're dealing with feet and inches, I'm gonna borrow 1 whole foot, so now I have 10 feet. Okay, you guys with me on that? So what's a foot in inches?
12
Oh.
inches.
So I've got 10 feet, 12 inches. That's the same as 11 feet. So now I'm gonna take 12 minus 6, which is 6. 10 minus 2, which is,
Eight.
so the distance between each side of the shelf would be 8 feet 6 inches. So I need to take that 8 feet 6 inches and divide it by 2, because there's 2 sides. So 8 divided by 2 is 4. 6 divided by, so it's 4 feet, and then 6 divided by 2 is 3. So on each side it's 4 foot 3 inches. And number 8 is like what we've been doing in chapter 4. It says a teacher let her students grade their math quizzes. John wrote 13 of 18. So John is writing, he got a 13 out of 18. Jim is writing that he got a 0 and 7/10 repeated. And Joe said he got 5/6. Who had the higher grade?
John.
Well, I have 2 fractions and 1 decimal. Can I compare fractions versus decimals?
No.
No. We either need to change it all to fractions and then come up with the common denominator, or change them all to decimals. I don't want to change them all to fractions and then have a common denominator. I just want to do one thing and be done. So I'm going to do decimals. 13 divided by 18. cause it's always numerators on the inside. 18 doesn't go into 13, so I add a decimal. Now 18 goes into 130
Calculate.
about how many times? Well, if I think 18 is like a 20, 20 goes into 105. I think it's gonna be about 7 times. So I'm gonna do 18 times 7. And that is exact, not exact, but 126. Borrow. 4 left, add a 0, bring the 0 down. 18 goes into 40
3.
twice. 3 would be too much. Cause 18 times 2 is 36. 4 left, add a 0, what's happening?
It's repeated.
So that's gonna be repeating. So John is 0.72 repeating. Jim is repeating the 7. So shouldn't I just add, if this has 2 place values, shouldn't I add another place value here? Yep. And 5, 6, I don't know, so I'm gonna take 5 divided by 6. 6 doesn't go into 5. Add the decimal, bring the decimal up. 6 goes into 50. 8, cause 8 times 6 is 48. 2 left, add a 0.
3 times.
3 times 18, what's happening? It's repeating, so I have a 0.83 with the 3 repeating. So now I have to compare. Well, if these have the tens places are the same, but the tens place here is an 8, so which one's greater?
Joe.
The 8, right?
Yeah.
So 5, 6 is a better score.
That'll
But
be-
we had to do the math in order to compare. You had to make them either all fractions or all decimals.